are going to continue our lesson by solving this question under linear programming. Then we complete linear programming. And I read, show by shading graphically the region S of all points xy which satisfies simultaneously the inequalities y is less than 2x, y is less than 16 minus 2x, y is greater than x over 3, y is greater than 0, and x is greater than 0. B, using the graph in A, find the values of x and y for which 3x plus y is maximum. The first thing we are going to do is, we have our inequalities here, and realize that we have y is less than 2x. So what we are going to do is, we are going to pick each of them. If possible, we find their x and y intercepts, okay? So we pick the first one in our solution. So in our solution, we pick the first one, which is y is less than or equal to 2x. So this can be written as y minus 2x is less or equal to 0. Okay? So for me to find my x and y intercepts, I'm going to change this sign to equal to. Okay? So this means that my equation now becomes y minus 2x is equal to 0. Then for x-intercept, put y equals to what? 0. So when y is 0, we shall have 0 minus 2x is equal to 0, minus 2x is equal to 0, x is equal to 0. I have 0, 0. Then when I find my y-intercept 2, okay, which is x is 0, you see that my y is also 0. So for y-intercept, we shall have put x equals to 0. So when x is 0, y is also 0. So I have 0, 0. So you can see that the line is passing through the origin, okay? And we learned in our previous lesson that if the line is passing through the origin and I have my equation as y minus 2x is equal to 0, I told you can give the coefficient of x to y, or you can give the coefficient of y to x. Now in this case, when x is equal to 1, okay? When x is 1, which is the coefficient of y is 1. So if I give it to x, so I'll say when x is equal to 1, we shall have y minus 2 times 1 is equal to 0, y minus 2 is equal to 0, y is equal to 2. So this means that x is 1, y is 2. So this is the second coordinate I can find. Apart from the 0, 0, 0, 0 passing through the origin, I have the second coordinate as what? 1, 2. So with these 2 points, I can draw the line y minus 2x is equal to what? 0. Then we move to the second one, which is, so this is the first one. We move to the second one, which is y is less or equal to 16 minus 2x. So I can rewrite this as y plus 2x is less or equal to 16. So for us to find our x and y intercept, I'm going to change this to equal to. Okay, so this becomes y plus 2x is equal to 16. So we find the x-intercept. So for x-intercept, put y to be equal to 0. So when y is 0, we shall have 0 plus 2x is equal to 16. 2x is equal to 16. X is equal to 8. So I have x is 8, y is 0. Then we find the y-intercept. So for y-intercept, put x to be equal to 0. When x is 0, we shall have y plus 2 times 0 is equal to 16. So we shall have y is equal to 16. So this means that x is 0, y is what? 16. So with these 2 points, as for this straight line, we are getting it directly, okay? We don't have 0, 0, 0, 0. Okay. Then we move to the third one, which is this, okay? So in our third one, we have 3y. I have y is greater than or equal to x over 3. When I multiply here by 3 and here by 3, I have 3y to be greater than x. So 3y minus x is greater or equal to 0. So this is another straight line. And I can change this to equal to, okay, if I want to find the x and y intercept. So I have 3y minus x is equal to 0. Now when x is 0, for x-intercept, okay, or for y-intercept, when we put x equals to 0, we realize that 3y will be equal to 0, y is equal to 0. So I have 0, 0. And then when y is 0, x is also 0. So I have 0, 0. So you could see that this type of line is just like the first one we just solved, okay? It is also passing through the origin. So what we do is, because I have 3y minus x is equal to 0, I am going to give the coefficient of, let's say, x to y or y to x. So let's say, I'll say, let's put x equals to, let's say, positive 3. I'm giving the coefficient of y to x. So I'll say when x is equal to 3, okay, the coefficient of y is 3, so I'm giving it to x. So I have 3y minus 3 is equal to 0, okay? So when x is 3, 3y minus 3 is equal to 0. 3y is equal to 3. 3y is equal to 3. We divide both sides by 3. We have y to be equal to 1. So we shall have x is 3, y is 1. So with this 0, 0 and 3, 1, I can be able to draw the line 3y minus x is equal to 0. Now, for y greater than 0 and x greater than 0, we don't need to find the intercept. So straight away from here, we can go and then draw our graph for these inequalities. Now, we pick, for us to get a reasonable scale, okay, we are going to consider the type of values we are dealing with in terms of x and y, okay? If there are negative values of x or negative values of y, we shall just be able to analyze it and see the best possible scale for the graph. Now, my values of x, I have 0, 0, 1, 8, 0, 3, 0. So my highest value for x is 8. So if I should make it 2 centimeters to 1 unit, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can make it 2 centimeters to 1 unit on the x-axis. So I have 2 centimeters to 1 unit on the x-axis. So I don't think I have any negative values of x. Let me see. There are no negative values, so we are good to go. Then we pick y. Y, we have the highest number to be 16. And the least value is 0. So 16. So with this, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll get 60. So let's make it 2 centimeters to 2 units on the y-axis. 2 centimeters to 2 units on the y-axis. So with this, I am going to draw the x and y axis. So because there are no negative values of y, I can go ahead and then draw my y-axis first. And I have my x-axis here. So after getting our x and y-axis, we said 2 centimeters to 1 unit on the x-axis. So we have our origin 0 here. We have 1, 2, so to 1 unit, 3, 4, 5, 6, 7, 8, 9, and then we have 10. Then we go to our y-axis, we said 2 centimeters to 2 units. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we are going to first start by drawing the first line where it passes through the origin 0, 0, 0, 0. So we mark 0, 0, 0, 0. So it passes through this origin, x is 0, y is 0. So we shall have 0, 0, 0, 0. Then we shall have x is 1, y is 2. X is 1, y is 2. So this is x is 1, y is 2. So with these 2 points in the origin, we are going to draw the straight line of where we have the 2 points. So the straight line of y minus 2x is equal to 0. So it starts from the origin. So this is the line y minus 2x is equal to 0. Okay? Now we are going to test for the line y minus 2x is equal to 0. So we are going to do our test. So the test for y minus 2x is less or equal to 0. Now, since this is the straight line, okay, we are going to pick a point below, okay, to test, or a point above. So if you should test and it is true, it lies there. If you test and it is false, if you should test and it is false, it doesn't lie there, okay? So we can pick a point below. Let's pick this point. X is 4, y is 2, which is below the line. X is 4, y is 2. So I'm going to test with x is 4, y is what? 2. So when x is 4, y is 2, so I have 2 minus 2 times 4 to be less or equal to 0. 2 minus 8 is less than 0. 2 minus 8 is negative 6. Negative 6. 2 minus 8 is negative 6. So negative 6 is less than 0. Now you ask yourself, is negative 6 less than 0? This is a true statement, okay? This is a true statement. So because it is true, and I use x is 2, y is 4 to test, which is below the line, it means our solution for this line lies below the line here. So the whole of this line is going down, okay? That is what it means. So the whole of this solution is going down like this. Now let's pick the second line. Y minus 2x is going down. Then we move to the second line. We have the point x is 8, y is 0. So we locate x is 8, y is 0. So on the x-axis, this is 8, 0. So we mark it. So we have 8, 0 here. Then we have x is 0, y is 16. X is 0, y is 16. So x is 0, y is 16 is here. So with these 2 points, so we have when x is 8, y is 0, and then when x is 0, y is 16. So we have that line here, okay? So when we draw it, we have this straight line, okay? Now we are going to test for this line. We are going to test. So for the second test, we are going to test for our test for the second line, which is our second test, which is y plus 2x is less than 16. Y plus 2x is less or equal to 16. So in this case, this is that line, okay? This is the line y plus 2x. We have the line y plus 2x is equal to 16, okay? So 0, 0 is below it. So you can see from here that 0, 0 is below it. So we are going to use the origin to test. X is 0, y is 0, okay? So when we do it, we shall have 0 plus 2 times 0 is less than 16. 0 is less than 16. Is 0 less than 16? This is true. 0 is really less than 16. So because this is that line, this is the line, and we use this to test, and it is true, it means the whole of this line is going down. Okay? So this is going down, and this is also going down. So if you watch, the whole of this is going down, the whole of this is going down. The two lines are meeting here. Okay? The two lines are meeting here. Because this cuts this at this point, and this will also cut at this point. So the two of them are meeting here. You can see all this is going down, this is going down. So they are meeting here. Okay? Now let's draw the next line. So again, we have when x is 0, y is 0, which is the next line, and you could see that this is x is 0, y is 0. And then our next line is, our next point is x is 3, y is 1. We have x to be equal to 3, and y is 1. So this is 3, 1. Okay, if this is 2, it means in the middle is 1. So we have 3, 1. So with 0, 0, and 3, 1, 0, 0, and 3, 1, we are going to draw the straight line of 3y minus x to be equal to 0. So let's draw that line first. So you start at 0, 0, the origin. And when x is 3, y is 1. So we draw the line. So we have x is 0, 0, and we have 3, 1. So you have that line here. So this is that line. So we have 3y minus x is equal to 0. So I have the line 3y minus x is equal to 0. Now we need to test, okay? So we need to test and see where this is lying. So over here, we shall have, we can pick a point below or above the line. So when we pick a point above the line, let's pick a point above this line. Let's say we pick this point. X is 4, y is 6. So we are going to use x is 4, y is 6 to test. So in our test, we shall use x is 4, y is 6 for 3y minus x to be greater or equal to 0. So x is 4, y is 6. So let's go. Y is 6, so 3 times 6 minus 4 is greater than 0. 3, 6, 18. 18 minus 4 will give us 14. 14 is greater than 0. Is that true? Yes, that is true. So this means that our solution for this one lies above the line because we picked a point x is 4, y is 6 to test, which is above this line. So and it is true. So it lies above it. So now, the next point we are going to talk about is y is greater than 0. If this is the line y equals to 4, y equals to 2, y equals to 6, y equals to 8, then this is the line y equals to 0. It is our x-axis. And numbers greater than 0 in terms of y are above. So our y is greater than 0 is rather going up. Okay? So we have values of y greater than 0 going up. So the whole of this line is also going up. Then we have x is also greater than 0. So if this is x equals to 8, x equals to 7, x equals to 6, x equals to 5, 4, 3, 2, 1, x equals to 0 is our y-axis, okay? So if this is our y-axis, we are saying values that are greater than 0, they are to the right. So it means the whole of this line is also going to the right. So with this, we are supposed to indicate where all these lines are meeting, okay? Where all these lines, these 3 lines we've done, where they are all meeting. Or actually it's 5 lines, okay? But this is our x-axis and this has become our y-axis, okay? So let's indicate where they are all lying. Now remember, this is going up, okay? This is going down, and this is going this way. So I can say they are all meeting. We have this point, 1, 2, 3, okay? So with these 3 points, I can shade inside and tell you this is where they are all meeting. So if I've been asked to indicate by shading where this region lies, then this is where they are all meeting. So what we are going to do is we are going to give the vertices, okay? The vertices of where they are meeting, or the region where they are all meeting. We shall give the vertices names. So I'm going to name this capital A, name this capital B, and then name this capital C. So I'm going to find the coordinates of A, okay? So my coordinates of A can be, this is 6.1, 6.2, 6.3, 6.4, 6.5, 6.6, 7, 8, 9. So 6.9. Okay, I have 6.9. So my coordinates for A, I have my A to be 6.9, comma, and then I look for the corresponding value of Y. So if this is 2 and this is 3, then this is 2.2. So 2.2. I have 6.9, 2.2. Then I go for the coordinates of B. For B, I realize that X is 4 and Y is 8. So I have 4, 8. X is 4, Y is 8. Remember, your X coordinate first before your Y. Then my C, I have the point 0, 0. X is 0, Y is what? 0. Okay. So with this, we have our vertices for A, B, and C, which tells us the region where they lie, okay? Where the vertices lie. So A, B, and C will tell us that. Now, find the value of X and Y for which 3X plus Y is maximum. So what we are going to do is we are going to draw a table. and we can only find the maximum where we have the vertices, okay? So we shall have our vertices here, then we shall have our function. Our function is 3x plus y, and then we shall have the value, okay? So we are going to pick the first one, which is a is 6.9, comma, and then y is 2.2. Then we come to the second one, b is 4.8, and then the third one, c is 0, 0. So we have the vertices. So we shall have, the first one is going to give us 3 times 6.9 plus our y is 2.2, so 2.2. Okay, so this is going to give us the value. We have 22.9. Then we have 3 times 4 plus 8. 3, 4 is 12. 12 plus 8 is 20. And then when x is 0, y is 0, we have 3 times 0 plus 0. This will give us 0. So we are asked to find the maximum value of x and y. So you can say the maximum value is, our maximum value is 22.9 and occurs when x is equal to 6.9 and y is equal to 2.2. So this is our maximum value, and this answers the question for B. So with this, I hope you'll be able to solve more questions under linear programming. If you have any question, you can put it in the comment section, and then I'm sure we'll be able to respond to you. Thank you so much. Until we meet again next time. Bye.